Voyager's new discovery shocks the entire space industry. It is no less than a shock to come to know that in 1978, two spacecrafts were launched in opposite directions into space to help us explore the interstellar space easily, and allow us to see places we cannot physically reach, and guess what? These spacecrafts are still traveling. They were named as Voyager 1 and Voyager 2. Recently, one of these spacecrafts, the Voyager 2, has discovered something that has shocked the entire world, and that's exactly what we will be looking into this video. What's up everyone? Join us in this video as we explore one of the most shocking discoveries you will have probably heard of till now. But before we hop into the video, consider subscribing to our channel and click the bell icon to stay tuned. Done? I'm sure you have done it. Then let's begin. Ever since the spacecraft has been launched, technicians and engineers have been monitoring it and controlling regularly. Since its launch, the spacecraft has been sending information every once in a while. Voyager spacecrafts are the very ones that gave us a detailed view of farther away planets such as Jupiter, Saturn, Uranus, and etc., which allowed the scientists to study the planets in a detailed manner. One of the major milestones of Voyager 2 was when it transcended the boundary of our solar system, after which it appeared sending signals unusual to the scientists. The Voyager 2 has been working as an eye for the humans into interstellar space and has revealed secrets we might never have been able to discover otherwise. After all, it's billions of kilometers away from us and still traveling at a speed of 38,000 miles per hour. But the question is, how has it been traveling for this long without any consistent source of energy? And by this long, I mean 44 years. The Voyager spacecraft would have run out of energy if it relied on solar power, because soon after its launch, it was far away from the sun to get any energy. Instead, the Voyager spacecraft uses radioisotope thermoelectric generators, often called RTGs, as their power source. Plutonium-238 is used as fuel for its energy, because when these isotopes decay, they generate heat energy which is converted into electrical energy. Although the RTGs have been powering the spacecraft well, the amount of energy generated by them has decreased too due to the decaying of the fuel. At time of its launch, the Voyager 2 spacecraft was producing 470 watts of power. However, a recent measurement in 2011 showed that the newer count was of 270 watts. Additionally, for the spacecraft to be able to communicate information to the Earth, its antenna must be aligned correctly, facing towards us, which takes energy too. And this process is critical, as without correct alignment, we would be unable to communicate with the spacecraft. For the reorientation of the spacecraft, thrusters are used which contain hydrazine as their fuel, and almost after 4 decades after the launch, the spacecraft switched to its backup thrusters, which are now working fine. The recent discovery that has spurred curiosity amongst everyone came to light when one of the Voyager spacecrafts, Voyager 2, transcended the Heliosphere of the solar system. Now, you might be asking, what is the Heliosphere? Well, let me tell you that our sun produces solar winds that diverge in all directions from the sun and travel far where the solar winds meet interstellar space. Now, the way two immiscible liquids don't mix well and create a visual boundary, the same way solar winds don't mix with the interstellar space well and create a boundary too. Our entire solar system is covered inside this boundary, which is called the heliosphere. The outer section of the heliosphere is called the heliopause, from where interstellar space begins. The heliosphere stretches 11 billion miles from the sun and acts as a shield, as it protects us from high-energy radiation in interstellar space, and without this shield, we might not have been able to live. NASA's most recent discovery that has shocked everyone relates to when the Voyager 2 crossed the heliosphere and entered into interstellar space. As Voyager 2 hovered into interstellar space, scientists observed a sudden increase in temperature, which was by more than expected and modeled. This is because a wall of hot plasma and cosmic radiation surrounds our solar system, which is incredibly hot, and is actually a physical barrier where temperatures ranges from 53,000 to 89,000 degrees Fahrenheit, which is more than the estimated temperature range. Now it seems fair and reasonable for you to dwell upon the mysterious fact and add fuel to the most logical question. How did the Voyager 2 survive so much high temperatures? The answer to this question is more logical than the question itself, and that's because the plasma is super thin and diffused at the same time, making the entire temperature around the Voyager 2 spacecraft low. This allowed the spacecraft to carry on its journey smoothly, yet scientists had a nail-biting time exploring all these facts and breaking them down into studies and discoveries. The Voyager 2 still continues the journey, however during its transition from the Heliosphere into the interstellar space, most of its function had stopped, making it impossible for scientists to monitor the data during the transition. Yet, we're able to measure the change. Moreover, it is vital to note that communication with the Voyager 2 is not a piece of cake, taking into account the distance it has traveled. It takes roughly 35 hours for the signals to travel to the Earth where information is received, and this time is continually increasing, as is the distance. The Voyager spacecrafts have discovered many things along their journey into interstellar space. The discovery of the hot plasma, referred to as the Wall of Fire, was the most recent one, yet sooner after its launch, the spacecraft Voyager 1 and Voyager 2 flew by different planets, and gave us closer looks of them in order for the scientists to study those planets more clearly and effectively. This involved the flyby of Voyager 2 by Jupiter, when it detoured its route of travel and went close to Jupiter to allow the scientists to study the planet and its atmospheric changes. The spacecraft sent back a time-lapse that gave scientists a look of the atmospheric changes on Jupiter, which allowed scientists to understand the behavior of the gas giant, and not just that, but the Voyager 2 also gave a closer look at the moons of Jupiter, which included the 4 major moons: Io, Europa, Ganymede, and Callisto. Following this flyby, the Voyager 2 went on closely to monitor the next planet, Saturn. Voyager 2 went really close, roughly 23,000 kilometers near the planet, and made such close observations possible for the first time. Scientists studied the planet in the best way ever and got to know more about the planet, its ring, and its moon. The Voyager 2 spacecraft did a great job, as it allowed the scientists to explore 2 of the biggest planets in the solar system and their moons. Voyager 2 then corrected its route as it went on to hover outwards from the solar system towards where it currently is today, the interstellar space. The recent discovery of the hot plasma neighboring the boundary of the Heliosphere has spurred another debate. Will the human travel to interstellar space not be possible due to extremely harsh conditions outside the Heliosphere, or will it be possible? Because considering the unprecedented data received by the scientists as of now, it doesn't seem possible. And if we just focus on the extraordinarily strong radiations out there, the Heliosphere, we can say it's impossible. But no one knows how will technology evolve in the future, and it's best that we should stay focused on our trip to Mars first, and that would be surely enough for now. Now to wrap up, things seem unclear as to how will Voyager 2 continue its journey, and what more surprises will it be sending our way. But we can surely expect some more discoveries to be made and more secrets to be unveiled, considering that the interstellar space is much vaster than our solar system. Another factor of concern would be how long will Voyager 2 be able to travel further and last, considering its thrusters are already on a backup. And once these thrusters run out of energy, communication with the Earth would not be possible. Because correct orientation is vital for communication to be possible, and that's what these thrusters do. What do you think will the fate of this solo spacecraft be? Will it be able to survive for another century, or will it soon lose communication with us? Comment your thoughts down below, and on that note, I will wrap up today's video right here. Don't forget to subscribe to the channel, smash the thumbs up button, and save us by the bell.